This is Bolt Identification Lab. We're going to get a little bit of practice on measuring fasteners. Mostly we're interested in Professor Hall's method of identifying the thread pitch. We've already discussed a math problem that's been in the reading material about SAE and metric thread pitches being almost identical. We've investigated it mathematically, and I have an example right here from our last lab experiment, and mathematically speaking, for what that looks like. So this is on the left SAE 16, and on the right is metric 1.5. This is what you run into. They are so close to the same. You can visually tell the difference. So when you're laying it on the threads, you think you've got a match. Fortunately, what happens is it's either just a little bit too loose and you don't get the right torque, or it slips just enough to strip in the hole. If it's a little bit loose, we calculated it's about 3 thousandths, it's right at 3 thousandths difference. 0.0035 to be exact, more exact. So if it's a little bit too small, whichever one's too small is smaller, then you might get stripped threads because it's not enough engagement of the threads. And if it's on the tight side, it might seize up or galled, or you'll attain your torque specification before the fastener is actually stretched. So that proves that point visually, and I'm through with that. What I have discovered is the best way to do it. A kit like this. This has all the sizes in it, and they are in the form of, I'll just take this one out. Internal threads on one end, external threads on the other end, and when you find a match, it tells you exactly what your diameter and your thread pitch is. I just happen to pick up M10. That means diameter is 10 millimeters, thread pitch is 1.0 millimeters between the peak of the threads. I started doing this because, well, everybody, I'm not the only one, but a long time ago I was buying fasteners and I knew exactly what size I needed. I pulled them out of the bin at the hardware store, got home, or wherever I was at the shop, and it turned out to be the wrong size. It turned out to be like an SAE. People put the wrong ones in the bin. People in the stores, they're not going to go through all that. So I always took a known good one with me to match up and be sure that what I was taking out of the drawer and paying for, so I wouldn't have to make another trip, was the exact same one that I wanted. We are We have 10 fasteners here. We're just going to go through them one at a time. There we are, 10. Then we're going to leave this up front here. Perfect. So we're going to start with number 1. And one of the questions that you have to answer is, what kind of head does this fastener have? And trying to get you a good picture here. That works. Yes. So that could be secondary. Actually, the first thing that has to be done is to decide what thread pitch do you have, what diameter. Once you determine the thread pitch with these, you know what the diameter is by looking at the side of the tool. This one is going to be, I don't know for sure. I'm just looking down in here, selecting one that's about the right diameter to see if it'll go in. The trick, the way this works is, if it screws in easily like that one is all the way, you've got the right fastener. I'll come back to that one. You got the right size. This one next to it, same diameter. The previous one was 10 by 1.0. This is 10 by 1.25. We'll also find one other one. This is also about the same as 3/8. So we're back around this SAE row. If it starts, this will start, and then it stops at about a quarter turn. I've had several beginners that work for me, and students, of course. This is a 3/8 by 16. Just start cranking hard on it, force it to go in. That's the wrong thing to do. It'll usually seize up when it's that tight. That's 5/16. That won't work. This could fool us. Not too loose. So our real size is, see how that's going in. This one. So I'll let you write that one down. That's what this fastener is. This is our number 1. Next thing we have to do is measure our thread length. Well, first we need to measure overall length from here to the base of the head, that doesn't include the head. And then the thread length on this one, it stops right here, stops a little bit short. So we're going to use a vernier caliper, and we'll make it, I think I'll use a digital one. This was metric. So this is our digital micrometer. First one you want to check and see if it's zeroed. This one is not. So we had it as a 0 button. Zeroed. Also has an inches to metric conversion. So since this is metric, we're going to measure everything in metric. And what does it say there on the scale? It says we're already in mm's over here on the left side. Mm. So we're good. We just have to crank it out to the length. And that's going to be our measurement. close enough. And this is our reading, so you'll be recording that. That's our overall length. Thread length is that. That's what it measures. The thread length. But that's it. We have our thread pitch, we have our thread length, we have our head type. And we're ready for number 2. Number 2. Looks like that. Number 2. Right off we see bolt length to the base of the head and the thread length are going to be the same. Head looks like that. So you need to decide what kind of fastener head terminology is used for that. And you already had an exercise in deciding what tool you would use for that. So all I have to do is find the thread pitch, and that's going to be one of these. It's obviously a coarse thread. See how coarse that is? What do you think, metric or SAE? Don't know. I'm in the SAE section. Don't think it's going to be. Nah. It started after I've done a lot of these, so visually I can tell pretty quick. Notice what's happening here. This is sort of starting, but it's stopped. I can't go anymore. That's a 7/16 by 14. After a while, you learn it's probably a metric fastener. After a while, you learn what the metric version is. So let's try a metric that's about the same. That's a metric, same diameter, but I can see that that is a fine thread. This is a coarse thread. Not going to work. One next to it is coarse thread. So that's a maybe. And this diameter is about 3 different thread pitches in metric. SAE only has coarse and fine and everything. So let's see if this one goes. Goes part way. And it stops. I'm trying to do this while watching the camera. So this is the next one. This is the same diameter in metric, 12 millimeter. What we're dealing with. You can see if you look in there. Yeah, they look pretty close, don't they? And so this should be it. I got it started. Didn't stop yet. Still going. That's it. So thread pitch gauges, we'd be pretty close on this one, that one. Would look very similar with a thread pitch gauge. So I'm running that by you again. So forget those thread pitch gauges. This one is that. So in 12 millimeter, you'll learn eventually there are 3 different thread pitches in 12. This is 12. And another 12. They also have a 1/0, they're kind of rare. Steering suspension stuff uses that sometimes. Can't find those at the hardware store. You're just kind of, yeah, 4-letter words come to mind on that. So we're going to measure our bolt length. Our handy dandy digital. There we go, close enough, doesn't have to be perfect. And we're still on the metric. It's because it's a metric fastener, so that's our measurement. This covers 2 of our requirements for information. Overall bolt length, thread length. It covers number 2. Next is number 3. Number 3. No identification. Head. Looks like that. These were hardware store bolts. Ground off the markings. So we don't know what it is. So we can figure it out. With these tools here, we can figure it out. No problem. So we know what the head is. We have, okay, same condition. Overall length and thread length are going to be the same. All we have to do is find a thread pitch, and the writing on the side of the tool will tell us. I know from experience it's either 3/8 or 8 millimeter. I'm going to think it's 3/8 coarse. Notice how that went all the way in. Yeah, I was wrong, that was 1/16. I thought that looked too big for 3/8. Let's see what we've got going here. No metrics close. Well, that started. You can visually tell it's not right. That's a 10 millimeter. That's the equivalent of the 7/16. So this is what it is. So write that down. We'll measure our length. Happens to be the same as the last one. Didn't move it at all. Well, maybe a little. Some measurement. And guess what? We said SAE. This is millimeters. If I push this button right here, it'll do the conversion for us. You gotta love it. So that's our measurement in inches. Tells us that down here in the corner. So you gotta stay on your game. This is a business of detail. You gotta be, so you can be close and get away with it sometimes. Engine rebuilding, not much forgiveness. Forget to tighten one bolt, motor breaks 5 minutes after you started it. Okay. Next is number 4. This is number 4. Really? There. Number 4. Got a head that looks like that. And again, our overall length, thread length are going to be the same. Figuring our thread pitch. This is in 5/16. Um, 8mm. I'm off on that equivalency. Speed. Probably metric. No, not. I'm going for 8mm. Didn't make it. Failed the ease of threading together test. It's the wrong one. Let's go for straight back, this one. What do you think? See what happens. We're in all the way. That's what that is. Thread length again. Right there. Take our reading. That was inches. We're still in inches. So that's it. That's number 4. Next is number 5. This is challenging. Just to see the number. It's hard to get something on there. 5. There you can tell number 5. This type of head, because it's small, they put a nut on the side. Those are used for like intake manifolds, exhaust manifolds. And the head of the fastener looks like this. It's a good view of it. So there is no bottom of the head. This is actually called a stud. So we're just going to measure the overall length, and that'll be everything. Because we don't know what the thread pitch is, do we? Got ahead of myself. Thread pitch is going to be what? This is in the 6mm range. No. This one got lucky. Went right in. We'll take that. You see how that just went right on in there? All the way. That is this one. So it's metric. And that means what? All dimensions on fasteners, if they're metric, then everything needs to be measured in metric. And we're pretty much right there, same length. And same distance, but we need a metric version of that length. So that's that in millimeters. So I need to look up a Google conversion calculator when you have that. That's number 5. Number 6. It's that. The head looks like that. threads look like that. Got a little bit of thread here, a lot of length up here. Kind of small in the middle, like a torque to yield fastener. They're always smaller right in this section. So let's get our thread pitch. It's a fine thread, see how close they are together? But we don't know. What do you think? We'll try SAE. There's one that looks the same. I didn't think it would be. You'd think since I set these up, but I've used this kit for quite a few years. I don't have them memorized. Well, this goes in all the way. This is the one, no point going any farther. And it is that size. So I'm putting that back up. We're going to measure our length. Inches, remember? So our overall length is that, which looks like this on our digital metric scale, but it's inches, so we have to push the blue button again. And that's the inches flavor of that length. Next is our thread length. We'll call it that. And that's the thread length. On fastener lengths, you can get away with some minor errors. Sometimes if I'm uncertain, I'll buy a little bit long and cut them off with a cutoff wheel. That takes a little practice to get that right. Put them on a grinder and around the end so it'll start. Sometimes use a thread tracer to, nice if you have that back in behind where you cut it off and it'll clean up on the way out. Next is number 7. Big old long guy. Got a head that looks like that. We've seen that. No, we haven't seen this before. Gotta look real close in there. I don't know if I have a light that I can shine in there or not. Afraid to. There, a little bit. I can always wave this one. Yeah, you can see that a little bit. That's not supposed to happen. It almost worked better. The overhead lights just turned off. It's an iPhone or magic. Everything still looks pretty good. I'll be darned. For some reason I wasn't putting enough body heat, I guess, for the overhead light sensor, and I thought nobody's in here. It almost made this better. The overhead lights almost give us too much light. I always have difficulty. Yeah, we're getting a little bit of reflection there, but that's working. Thread pitch. We're going to have our thread pitch. And we're almost done. It's going to be. This is going to work. Got lucky again, took off. Wait a minute. I thought it stopped about halfway. Sometimes I'll do that to you. No, this is it. 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 This is So that's our thread pitch and our diameter. I'm not telling you all these because I want you to get used to that nomenclature on fasteners where they, you know, the capital M always usually means meters, but when you're talking about fasteners and they put it in front of, they're talking millimeters of diameter. So this is our overall length. That was metric. We are inches. We have to change our magic blue button. That's the metric flavor of that length. Trying to get a little reflection so you can see that it says mm in the scale. So that's our overall length. Thread length is a little bit less. So there's our thread length. In millimeters. Next is number 8. It's a head that looks like that. Overall length is different than thread length by quite a bit. So what's the thread pitch? It's a fine thread. After a while you get a memory for that, and those are close together, so you just remember. Close together like, yeah, here's a comparison. Your brain adjusts and goes, oh yeah, there's a coarse thread, that's the next one up, number 9. That's a much coarser thread. We don't know, they could be metric, or we don't know. So let's figure out what this one is. It's a fine thread. Every time I see hex, I think SAE. That's why I got lucky again. I'll take it. I may show you one other just to kind of reinforce that. So this is what this is. And I'll just show you. That's going to be in the 12 millimeter range. These were coarser. That was 175, 150, 125. 12 millimeter, 125 might be close. And it actually went all the way. The difference being, and this is where that couple of thousandths difference makes a difference. So this is M12 by 125. Students often miss this in this lab. Here's what's going on. Notice how much I'm going back and forth. That's too loose. They're close enough. That goes together. This is when, notice when I'm tightening it, it kind of kicks up a little bit. But it feels like, yeah, it goes in there. It's no hanging up or anything. Look at that. And it won't pull out. You put some torque on that bad boy, it'll come out. Now let's compare to this one that we already decided it was. Going in just as easy, but look at this. I can feel it wiggle, but just barely. And it's, yeah, so. That's why you gotta have a tool like that, and you gotta be on your game with detail. Overall length. We said it was an SAE, didn't we? So we're gonna have to change our, and push our blue button again, huh? So we did a metric last. That's our overall. Got the wrong flavor of units. That's it in that length in England would look like that. Yeah. Next is our thread length. There. Next is number 9. Number 9. Thank you for drawing a line on the bottom of that 6, or on the other end of the 6, or the top of the 6, or whatever, so that it turns it into a 9. That's what our head looks like. And it's a coarse thread. What is it? Could be a 12. Oh my. Maybe. Went right in. Is it a fool us again? Oh, look at that. Now I know why students miss these. When I'm grading these out of the lab book, these last ones, students would miss them. See how loose that is? That's not right. That is not right. That's an M12 by 1.75. This is going to be an SAE. It's going to be up here in this range probably. About where we were before, maybe the same exact. This is it. No more loose. Goes right in all the way. That's what it is. It's not a 12. We have overall length different from thread length. Where are we at? We're still in England. So that's our overall length. Thread length. It's our thread length. And number 10. So we're getting a lot of good examples on, even with a good tool, no thread pitch gauge, we can still be fooled. You gotta be on your game for detail. You gotta be thinking all the time in this business. Those little things, you get bored, you go, whatever, thinking about the other parts of your life and not paying attention, you'll get in trouble. So number 10, I'll keep covering it up. Got a head that looks like that. This is one of those I've been talking about. This has got the manufacturer's head markings on there. That's an 8. Sometimes that does correspond with the metric. Some of the import manufacturers do put a grade value in there. I believe that's what that means, but it's inconsistent with the hardware manufacturers selling the hardware stores. Aftermarket, they are the same people that make it for the car manufacturers, but they put their markings on them. This is going to be probably a metric. Didn't work. Stopped. It's a fine thread 8. It's a 1.0. That didn't work. Here's an M8. M8 1.25, that goes in all the way. So this can fool you too. So we're in the right range of diameter. I'll show you here. This stops pretty quick though. You can force it. You'll be having a bad day over it. I try to change my thinking on that bad days logic. It helps. My new saying is, all days are good, just some are better than others. I screw that one back in here. This is it. Overall length. It's going to look like that. I was anxious to be done, wasn't I? Then we decided it's metric, so we have to get back across the water. Then we're not coming to America either because Americans are all messed up on that. So that's it. Then the rest of the planet. Overall length. Thread length. Just like that. I think you can see that. Yeah. Okay. This concludes the video on Fastener Identification.